Good evening to you and Happy New Year. Welcome to this video session. We thank God for the new year. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, as usual, aka Sam Dom for Peace. In this video we shall discuss rational inequalities. Please, it is recommended that before you view this video that you have a good knowledge of inequalities. At least you know how to solve, graph and check the solution of inequalities. It is also recommended that you have viewed the videos on quadratic inequalities, polynomial inequalities before you continue with this video. Actually, this is a video playlist. You can get the video playlist on this website, www.inequalities.appspot.com. Again, I repeat, www.inequalities.appspot.com. So it is recommended you know those, okay, have the good idea, good knowledge of those prior to viewing this video. Also, it is recommended that you have an idea of rational numbers and rational functions. We define a rational number as any number in the form of P over Q, where Q is not equal to 0. The denominator is not equal to 0. So we define a rational number as that. And if you go to my videos on that, numbers and notations.appspot.com, it defines numbers, including rational numbers. So it's important that you have an idea of what is a rational number. Then, what is a rational function? We define a rational function as P of x over Q of x, where Q of x is not equal to 0. So this is a rational number. This is a rational function. Now we get to rational inequality. So, with rational inequality, you have to be extra careful. It is not difficult at all. It is not. By the grace of God, by the time we finish the problems I have here, is a lot of them, you would have a good understanding of it. Some students I know complain about rational inequalities. It is not difficult. When we talk about inequalities, you know the two basic things about inequalities. Of course, you don't expect it to be, you don't expect it to be as easy as rational equations, equality. I mean, come on. What is one of the major problems we have in this world? What do you think? One of the major issues we have in this world is inequality. Okay? If you think you're greater than me, or if I think I'm greater than you, it becomes a problem. When everybody is not treated equally and fairly, that is the problem. So it is not just in mathematics. It is not just in real life. Inequality is not just a problem in real life, in sociology. Inequality is a problem in mathematics. That's why you have to be extra careful when you solve this. So you need to have that knowledge of inequality. Then rational number, rational function. Now, as you can see with rational function, we know this is a fraction. And some people don't like fractions. Okay, no problem. It's not, you will get it. Okay, just be focused and be positive. You're gonna get it. Okay, so you will need to know that the denominator is not going to be equal to 0. So if you can find the domain of that function, then when you're writing the solution set of the inequality, you have to be careful because of the domain. Okay, because of the domain of that rational function. So rational inequality is just an inequality of rational functions. That is what it is. Just like rational equation. Rational equation is an equation containing rational function. So rational inequality, and you can take down all these definitions. The transcript of what I'm teaching is on this website. Okay, so the transcript of what I am teaching is on this website. So you can, as your list, it will be good. You can take down, that's fine. You can also go to this website to look at the transcript. But as I am solving, you don't need to be writing. You need to pay attention. When I'm solving a problem and I'm explaining it, you don't need to write. You just need to pay attention. Okay, like I said, the transcript is on this website. So after solving a question, okay, for each question I will try to solve it 4 ways, 4 different forms. I'll try to solve it with less than, with greater than, with less than or equal to, and then greater than or equal to. So for each question, I'm going to solve it this way. So if I solve it one way, pay attention. Okay, you don't write, just pay attention. Then after solving it one way and you understand it, then you pause the video and solve it the next way that I have to solve it. Okay, that way you solve it and then it makes sense to you. I'm gonna try as much as possible to break it down. But after teaching it, if you have any questions, feel free to ask me. Now, when you ask me questions, just know you have to be patient. Okay, now if you're my student, I must answer you right away because it is my job description. It is part of my job. It is part of my job description to respond to my students. So I respond right away. But if you are not my student, okay, no problem. You can still ask me questions from my website. But please be patient. Don't expect me to answer it right away. No. Okay, so please be patient. Okay, so we say that rational equation is an equation that contains a rational function. And we did videos on it. I called it fractional equations. We have done videos on it. Now we are going to do rational inequality. A rational inequality is an inequality. This is inequalities. Has to be like less than looks like an L. Then the other form is greater than, or less than or equal to, greater than or equal to. So if you see any inequality that contains rational functions, it is a rational inequality. That is the simple definition. Okay? That is the simple definition. So let's get started. We've talked so much about this. Let's see it in action. The nice thing, usually with my students, I ask For equations, we say solve and check. You know, if you're my student, that is customary. Okay. If you take me for any class and it deals with equations, I am solve and check. Period. You can't just solve without checking. No. Solve and check. That's Mr. C. Now, for inequalities, it is solve, graph, and check. 3 things. The nice thing about rational inequality is before you eventually get the answer, you have already checked it. Okay, so you will need to check it before you actually get the solution set, you know, to actually get the answer. So we're going to solve it. And before we actually get the answer, we'll check it right away. So we don't need to do another check. We are going to write our answer in interval notation, and then we graph it. Okay, so that is what we are going to do here. So let's start with number 1 I have here. I have 1 over x plus 10 is greater than 0. I will start with the greater than, and then we can we will do, like I said, we are going to do each of these forms. When you're solving rational inequality, okay, we're going to do varieties of questions. So you know, we're going to cover almost, you know, the basic varieties. So you know how to actually go about solving it. So let me say this, okay? Here we don't have a plus sign. I know it's just greater than. However, when you're solving rational inequality, the first thing you want to, you know, when you're solving it, is if you want always 0 to be on the right hand side. Okay, because this is a rational function. Okay, you know that 1, you can call it 1x to the 0. You know that, right? It's a function of x. You know, p of x is 1, and you might say, okay, what is the x there? Well, it's x to the 0. Okay, so this is a rational function, and then this is the inequality. So it is a rational inequality. You want the 0 to be on the right hand side. Only the 0 to be on the right hand side. Anytime you're solving rational inequality. So here in this case, we already have the 0 on the right hand side. So we're good. Okay, we're going to do problems where the 0 is not on the right hand side. So that way you can know how to solve it. So that's the first thing you have to note. The 0 on the right hand side by itself. If it is not, you have to manipulate it. Okay, so that only 0 will be on the right hand side. The next thing you want to do is you want to write what should not be in the domain. Okay, the next thing is making sure that you have only one term on the left hand side. So I said number 1, have 0 to be on the right hand side. Step 1. Step 2, have only one term. One term. You shouldn't have addition or subtraction of terms, no. Just have only one single term to be on the left hand side. So as you can see here, we have only one single term on the left hand side. Remember, first thing, 0 should be by itself on the right hand side. Okay? Second thing, a single term should be on the left-hand side. Okay? Now, the next thing you want to do, step 3, is write everything, all the values that should not be in the domain. I understand that there is no equal to here, but it's just a safe practice. Okay, some people will say, okay, why do you need to write that? This is not greater than or equal to. That's fine. It's a safe practice. What should not be in the domain? Okay, what number should not be in the domain? So as you can see here, x should not be equal to -10. So, because you do x plus 10 equal to 0. So, x, because remember, the denominator should not be equal to 0. Okay, remember, x plus 10 should not be equal to 0. So x should not be equal to -10. -10 should not be in the domain. So take note of that. Okay? It is not really important for inequalities that don't have equal sign, but it is just a good practice. It's just a good practice. Okay? Now for inequalities that do have equal sign, such as less than or equal to, or greater than or equal to, you've got to note that. Must, has to. Okay? Because it is important in writing the final solution set of the inequality. So, -10 would not be in this domain. Okay, because if -10 is there, then 0 will be denominator. Can you divide anything by nothing? Is it possible? Can you divide anything by nothing? Can you create something out of nothing? No possible. No es possible. No way. Only God can do it. El Señor. Only El Señor can do it. So you can't divide anything out of nothing. No way. So only God can do it. Okay. So -10 would not be in the domain. Step 4. When we did quadratic inequalities, we used the sign graph method. We used one method. Okay, remember it's 2 methods, but I taught one method on that. Okay, on the video on quadratic inequalities. I use the sign graph method. Okay, in this video, I'm going to use the second method, which is the test point method. Okay, folks, I'm just going to use that method here. If you want me to use the sign graph method, okay, send me an email or contact me from my website, okay? However, in this video, I shall use the test point method because it is much easier. Okay, it is much easier. Much easier. So, and this video is going to be long. Okay, I hope you are ready to do some mathematics with Mr. C. Because this video is going to be long. It will be long. Okay. Okay. So, I am going to use test point method to save time. Okay? Okay. Alright. So, how do we go about the test point method? We are going to look at both the numerator and the denominator on the left hand side, because remember we have only 0 on the right hand side, and on the left hand side we just have one single term. Okay, so we are going to consider both the numerator and the denominator when we are solving this. We are going to determine the test points. That is the points at which we are going to test the rational function, the inequality actually, to see if it satisfies the inequality. So we can get the intervals, that's the solution set. We can get the intervals that satisfies that inequality. We are going to represent our answer in interval notation. So you look at the numerator here, it's just 1. Okay, don't worry about it. It's just a single number, 1. 1 doesn't have the variable there is x to the 0. So it doesn't really give us any test point. So we don't use the constant at all. Then we look at the denominator, we get x plus 10. So what we are going to do is this. We will do x plus 10 equal to 0. So x is negative 10. Alright. We are now going to do our test point. We now have only one test point. Only one. So we draw a number line. We'll draw a number line. This is our number line. And we'll just put negative 10. That is only one test point. One test point. However, the negative 10 has made it to have 2 intervals. It is one test point, but 2 intervals. So if we draw the line here, I'm just going to use a yellow chalk. I use a yellow chalk to draw the line to demarcate the intervals. As you can see here, the interval here is x is less than negative 10. Because all the numbers less than negative 10 are to the left of negative 10. The interval here is x is greater than negative 10. All the numbers on the number line that are greater than negative 10 are to the right of negative 10. Okay? So we will just say here, for this interval, we'll just say let x be, just pick a number that is less than negative 10. Any number at all. We'll just say negative 12. Let's just say negative 12. So we come here, in testing for this, okay, we'll just test it. We'll put 1 over negative 12 plus 10. And that gives us 1 over negative 2. And that is negative 1 over 2. Negative 1 over 2. You ask yourself, negative 1 over 2. Remember, this is the inequality greater than. So a student might ask me, okay, students will ask me, okay, hey, Mr. C, hold on. First step, make 0 to always be on the right hand side, only it. And then make one term to be on the left hand side. Why 0? Alright, for this question I'm going to answer it. For some other questions, I will tell you when we check, you see how we check it. Because, it's a little bit, Okay, so it is easy. It is very easy to find out. It is very easy to use 0 as a reference. Okay, because if anything greater than 0, we know is positive. Anything less than 0, we know is negative. Right? So if 0 0 is neither positive nor negative. 0 is not positive, 0 is not negative. 0 just separates the positive numbers from the negative numbers. So, when we do this, when we check here and we get a negative number is not greater than 0. Negative number is not greater than 0. So we know that any number here will not work. No. Any number in that interval is not going to work. So you see how we check it already. This is like check as you solve kind of thing. Okay? It's really good. You don't need to, you have to check it before you even get your answer. I like this a lot, you know. So it tells you right and there, it's not gonna work. Any number in this interval will not work. Okay? Then we now say, okay, for this particular one, let x, we pick any number here, any number at all, any one. And the easiest will be what? 0. The easiest is 0, right? That's the easiest number to pick there. So, and you can pick any number. You can pick -9. You can pick, if you pick -9, you will still get a positive number anyway. If you pick -9.9, you'll still get a positive number. If you pick -5, you're gonna get a positive number. If you pick 200, of course, it's all positive numbers. So, but I just want to pick easiest numbers. Okay, so this will be 1 over 0 plus 10, which is what? 1 over 10. 1 over 10 is positive. It's greater than 0. It is greater than 0. So any number here will work. Can I write yes here? Okay, I write yes there. So this will now be the solution of this would be, let me write the answer here. The solution is going to be from -10 to infinity. This becomes a solution from -10 to infinity. -10 is not included. It is not included in the domain at all. Even if there was equal to here, we are going to do that. So you see. Comprende? Does it make sense? Does it make sense? And you know, because we'll do a lot of problems here. So we're gonna just leave graphing. There's a graphing calculator on my site, a calculator on the site, okay, that will solve these, and also graph it. So you can check those. You can check everything we're gonna solve today. You can check it with a calculator on this site. That will solve it, that will graph it on this site. Yeah, so because of time, because we're gonna do a lot of problems, we will just solve it, and of course check it, because this is like check as you go. Okay. This is of course, graphing it is not a problem at all. Graphing it is not a problem at all. But because of time, you know, this is our 0, these are -10, and this is from here, -10 to infinity. You just draw it like this. Or you can also have an open interval, an open circle, -10, okay, open circle, to tell you it is not included. Now, but because of time, we shall just solve these, okay, and check it. Of course, before we find our answer, we will check as well. We have already checked. Okay, so we've done this. For greater than 0, this is the solution here. Now, what if it is greater than or equal to. Number 2, question 2, if we have 1 over x plus 10 greater than or equal to 0, it still does not matter. Negative 10 will not be included in the domain. Negative 10 will not be included in the domain. It still doesn't matter. Negative 10 will not be included in the domain. So the solution is from negative 10 to infinity. Negative 10 is still going to be open. It's not included. It's an open interval. It is an open interval. It will not be included in the domain. So, regardless that you have equal to, okay, you still have to open this. This is still open at negative 10 because it is not included in the domain. That is the importance of writing what is excluded from the domain. Okay, now number 3. Let me go ahead and now erase this graph. Now number 3, if we have 1 over x plus 10 less than 0. So you can pause the video now. Like I said, each case we will do this 4 times. So if you understood it, then you can pause the video, then write it, solve it, then you now, play it. So the solution here, the solution is from negative infinity to negative 10. Because less than 0 is negative. Less than 0 is negative. Because this is negative and this is positive. Okay, that's negative and that is positive. Oh, I wrote it like physics. Okay, if I decide to write like math, I put it like math. This is like physics, negative. Okay, if I decide to write like math, I just write minus. But this is plus B is physics. Then I just write plus here. Okay, I now write it as math. Okay, so that is the thing for that. And then for the last one, number 4, 1 over x plus 10 less than or equal to 0. The solution is still negative infinity to negative 10. That is it. That's it. Okay? Alright. Number 5. Let's do number 5. Here we have a negative 1 over 7x plus 9. Negative 1 over 7x plus 9 greater than 0. So I would like to do all varieties. So let's do all the varieties. Let us find the thing that will not be in the domain. So here, 7x plus 9, let's say is equal to 0. 7x is minus 9. So x is minus 9 over 7. Okay. Now, not included in the domain. Okay. The domain will not include x should not be equal to negative 9 over 7. So, negative 9 over 7 should not be included in the domain. It should not. And as you can see in this case, our test point, we only have one test point, which is negative 9 over 7. The numerator, negative 1, is just a constant forget about it. Okay? It is only useful when we test our intervals. When we test the intervals. So our test point in this case is just 1, and that is negative 9/7. So let's find it. Pick any, here the interval here is x less than negative 9/7. Here is x greater than negative 9/7. Okay, pick any number. Negative 9/7 is about negative 1 point something. Right? Negative 1 point something. So we can pick negative 2. So let x be negative 2. Let x be negative 2. So we have negative 1 over 7 times negative 2 plus 9. And that gives us negative 1 over negative 14 plus 9. And that gives us negative 1 over negative 5. Right? Negative 1 over negative 5. Which is what? 1 over 5. 1 over 5 is positive. So this is positive here. Positive. Okay? And because it's greater than 0, this is yes. This is yes. Now let us test this. We pick a number here. Let's just pick 0. Easy way. 0. Let x be 0. So this will be negative 1 over 7 times 0 plus 9, which is negative 1 over 0 plus 9, which is negative 1 over 9. So it is negative. It is negative. And because this is greater than, okay, this will be no, it won't work. Because negative numbers are not greater than 0. Are not greater than 0. So, for the greater than, so solution for, okay, the first one, negative 1 over 7x plus 9 greater than 0. This one is, the solution set is from negative infinity to negative 9 over 7. Right? And the same thing for greater than or equal to 0. Greater than or equal to 0, because negative 9 over 7 should not be included in the domain. So the solution is from negative infinity to negative 9 over 7. Right? For negative 1 over 7x plus 9 less than 0, the solution is less than 0 means it should be negative. So this will now be yes in this case. Okay? This place will now be yes. So this is from negative 9 over 7, not included, okay, to infinity. This means that any number you pick here, when you substitute it in this inequality, it will be less than 0. That is the meaning. That any number you pick there, the test points are just demarcating the intervals, the test intervals. You have 1 test point, 2 test intervals. So it just tells you that any number you pick there in that interval satisfies that inequality. That is what it's telling you. It satisfies the inequality. So here also negative 1 over 7x plus 9 less than or equal to 0 is negative 9 over 7 to positive infinity. So this is number 5, 6, 7, 8. We've done 8 problems now. We've done 8 questions. So the next one will be question 9. Question 9. Question 9. The next one is question 9. Question 9. Question 9. Okay, question 9. Yeah, we're getting there. 3x over x plus 7. 3x over x plus 7 greater than 0. Right? So we're getting, it's step by step. Here we have now, we are going to consider. Now the first step, 0 is by itself on the right hand side. Okay. Second step, only one term is on the left hand side. Okay. Now we're going to consider the numerator and the denominator. We have to consider both. But before we do that, third step, what should not be in the domain? So, let's first of all find x plus 7 to be 0. So x is minus 7. So x equal to negative 7. X should not be equal to negative 7. Negative 7 should not be in the domain. It should not. It should not be in the domain. Okay. Alright. Now, negative 7 is also a test point. As you can see, the domain is part of the test point. Right? Okay. So, negative 7 is our test point. That's one test point. Let me put it asterisk, one of the test points. We also have to consider the numerator. In this case, the numerator is not a constant. It has a variable. It's linear. We have to consider it. So we set it to be equal to 0, just like we set the denominator to be 0. Okay, in rational inequality, you have to set the numerator equal to 0, find the test point. You also have to set the denominator equal to 0 to find the test point. It's not just the denominator that you use to find the test points. You use both the numerator and the denominator. Okay, Mr. C, why didn't you do that in questions 1 through 8? Well, questions 1 through 8, the numerator is just constant. We can't set it to be equal to 0. That would be contradiction. Okay. It's just constants. Okay. But in this one, the numerator is not a constant. It is linear. So we have to set it to be 0 to find the test point. So 3x equal to 0. So x is 0. This is our second test point. Alright. We will now I'm gonna come here and I hope I can use this here. Okay, so we now come and get our test point, draw a number line. We draw a number line. And we put the test points, negative 7 and then 0. So we have 2 test points, but now those 2 test points gives us 3 intervals. 3 intervals. Those 2 test points now give us 3 intervals. Okay, now this will be x less than negative 7, negative 7 less than x less than 0, and x greater than 0. Okay, so as you can see it here, 3 intervals. The 2 test points now gives us 3 intervals. Now we've got to test it. Test the intervals. So the first one, here, let x, we pick just what is the easiest number? -8. -8. So we have 3 times -8 over -8 plus 7. And that gives us what? -24 over -1. And that gives us 24. 24 is greater than 0. So I'm going to put positive here. I'll put positive here, and I'm going to put yes. Because for this question it's yes. See that? Then I'm going to come here and test. Pick a number here, pick a number in this interval. Easiest one will be -1. -1. Okay? Let x be -1. So this will be 3 times -1 over -1 plus 7. Right? So this is -3 over 6. And that is -1 over 2. That's the negative. And because negative is not, negative number is not greater than 0, it is a no. Comprende? Then I have to test this interval. Let x be 1. I'm just picking the easiest numbers to test. I mean, you can put 2, 3, 4, 5 if you want to. But anything greater than 0. Right? So this will be 3 times 1 over 1 plus 7. And that is 3 over 8, which is positive. Positive number is greater than 0. So I put plus here and I write yes. Okay? Now I can come here and write solution for 3x over x plus 7 greater than 0 is, I'll look for the ones that has yes. So this is from -infinity to -7. Now -7 is not included in the domain. So I'll put the parentheses. Then union 0 to infinity. So you use the union to join solution sets. In this case, you have 2 intervals that satisfies the inequality. And because you have 2 intervals that satisfies the inequality, then you have to use union. Because this is interval notation, you can use union to join it. Okay? So that's the solution set in interval notation for greater than 0. Does that make sense? Okay? Now, the next thing we'll do is greater than or equal to 0. 3x over x plus 7 greater than or equal to 0 is, so greater than or equal to 0, I want you to look up. We have the yes and yes because it's greater than or equal to 0. So this here will be -infinity to -7 union. However, 0 can be included because of the equal to. If we have equal to here, okay, this now question 10. If we make this now question 10, because that's question 10. equal to. This means that we still can have -7 in the domain. We cannot have it. Because if you have -7 here, this will be 0. However, you can still have 0. You can, because of this equal to. 0 is included. Because if you say let x to be 0, that would be 3 times 0 over 0 plus 7. And that will be 0 over 7, which is 0. However, 0 is greater than or equal to 0 because of the equal to. Because of the equal to, 0 is also greater than or equal to 0. Just like 5 is greater than or equal to 5. Does that make sense? Okay, so in that case, 0 is included. So you use the closed interval. It closes at 0 up to infinity. You open infinity because you can't have the greatest number in this world. Neither can you have the least number in this world. That's why you open negative infinity, open positive infinity. So, but you have to close 0 because 0 is included in the domain and 0 works. Does that make sense? Okay? Comprende? Does it make sense? Okay, now, what of less than? If we have 3x over x plus 7 less than 0, it will just be only because minus, only minus, because negative is less than 0. So, and remember, -7 is not included. Anyway, now -7 is not included anyway. Now, but 0 will not be included because there is no equal to. Okay, so this will be from -7 to 0. Open it. Open interval. And then if it is 3x over x plus 7 less than or equal to 0, the solution set is from -7, because -7 is not included in the domain. However, 0 is included. 0 and you close it. And you close it. Questions. Okay? So that is it, folks. That is it. That is it. Is it difficult? It's not. Okay. We've done 9, 10, 11, 12. So the next one will be 13. Question 13. Question 13. Question 13. Question 13. Question 13. Here we have x minus 4 over x minus 7. X minus 4 over x minus 7 greater than 3. Okay. You know, we are coming, like, right? We are doing this step by step. We are coming in. We are now getting there. We're now getting there. Let me make sure I wrote this well. Yeah. So we're now getting there. So here, and please, I want you to pay attention because once we've been doing the 12 we've done, it was pretty much straightforward. So in this case here, first step, 0 should only be on the right hand side. Well, is 0 only on the right hand side? No, we have 3 on the right hand side. Okay, So that case, we have to move 3 over to the left. We gotta do that. Okay? So we now have x minus 4 over x minus 7 minus 3 greater than 0. Just like we're solving the equation. Right? Then, we now have only 0 on the left hand side. Okay. I mean on the right hand side. We now have only 0 on the right hand side. Okay? However, the second step, we need only 1 term on the left hand side. How many terms are on the left hand side now? It's 2 terms. We gotta have only 1 term. Only 1 term. 1 term. Only. Uno terminus. Okay, only 1 term. Only. So, so this will be, this 3 is like saying x minus 4 over x minus 7 minus 3 over 1 greater than 0. That is like saying that. Okay. And please, 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 if you don't know how to solve rational expressions, go to my website, there are videos on that. Okay, rational expressions, rational equations. So I would assume that you know how to solve rational expressions because that is what is on the left hand side. We have to make it only 1 term. So LCD here is, so I'm going to assume that you know it, how to solve it. It's x minus 7. That's the LCD, x minus 7. So this into this is, you know, this is x minus 4 minus 3. I'm going to put this in parentheses. 1 into this, 3 times x minus 7 greater than 0. So if you did not understand what I just did now, okay, because if I start teaching this, then it will take more time. Then you will start complaining, hey Mr. C, this video is too long. Okay, so if you don't, I hope you understood how I got from here to here. If you did not understand how I got from here to here, please go to my website, view the videos on rational expressions and rational equations, please. Okay? Now this will now give us what? X minus 4, you distribute, minus 3x plus 21. Okay? You distribute, minus 3x plus 21 over x minus 7 is greater than 0. So x minus 3x is minus 2x. Minus 4 plus 21 is what? Plus 11 minus 4, 17. Okay? Over x minus 7 greater than 0. Right? So minus 2x plus 17, excuse me, minus 2x plus 17 is greater than 0. Minus 2x plus 17 all over x minus 7 is greater than 0. Okay, as you see here now, you now notice that you now notice what? What do you notice? You now have only 1 term on the left hand side. You have 0 on the right hand side. You now have only 1 term on the left hand side. Alright. The next thing we're going to do now is to find what will not be in the domain. That's what we're going to do now. We'll find now, after you've done this now, we'll find what will not be in the domain, and we will also find the test points, so we can find the test intervals. Alright, so we have, I'm going to come here, let me let me actually, because I will need space. So I'm gonna erase this. I will leave this main one. I'll leave this main one so you see it. And please, like I said, everything I'm solving now is on this website. Everything I'm solving is on this website. Okay, so the transcript is on this website. Or you can pause the video and play it again. Or you can view you can be reading the website, you can be viewing the video and looking at the website, whichever you want. So I now have this minus 2x plus 17 over x minus 7 greater than 0. Yeah, because I will need this space. So x minus 7 is equal to 0, x is equal to 7. Now, our domain, x will not be equal to 7. Our domain will not include 7. Our domain will not include 7. And 7 is also a test point. The next one, minus 2x plus 17, the numerator is equal to 0. Minus 2x is equal to minus 17. So x is minus 17 over minus 2, which means that x is equal to 17 over 2. So these are our test points. We have 7 and we have 17 over 2 as our test point. Alright. We now get the test intervals. So I'm going to come here. I have 17 over 2 is 7 is 14 over 2. So 7 is 14 over 2 and then 17 over 2 is greater. So I have 7 here and I have 17 over 2. Because 7 is 14 over 2. 17 over 2 is 17 is greater than 14. Okay, so 17 over 2 is 8.5. Alright, folks. But you can do it for 7 is 14 over 2 and 17 is greater than 14. Okay, they have the same denominator. So just compare the numerator. Alright, so I now have the test intervals here, here, and here. So here will be x less than 7. Here will be 7 less than x less than 17 over 2. Right? And here would be x greater than 17 over 2. Excuse me. Alright. So now, this is where you need to be very careful. I mean, it's not as if you have not been careful all along, okay? But here, you have to be very, very careful. When we check this here, you have to now check with the original inequality, not the modified. Now, this is the original inequality, original as is. Remember, when I taught you equations, linear equations, quadratic equations, cubic equations, absolute value equations, higher order equations, radical equations, rational equations, I ask you to do what? Check with the original equation. Remember, when we did inequalities, you also check with the original inequality. Now, the nice thing about rational inequality is that before you get your answer, you would check anyway. So it eliminates that second check again. It eliminates it. So when you're checking this now to solve this problem, do not check it with the modified. This is the modified. No, we will not do that. No. We're not going to check it with plus or minus now, like we did for the past 12 problems. Now, we're going to check it with the original inequality is the left-hand side greater than 3. That is what we want to know. Okay? So I'm going to come here. We'll say let x, we pick, easiest number here is 6. Let x be 6. Let x be 6. So we'll say here 6 minus 4 over 6 minus 7. This is what? 2 over negative 1. This is 2 over negative 1. Right? Let me write it here. So this is equal to 2 over negative 1, which is what? Negative 2. Negative 2. Negative 2 is not greater than 3. Negative 2 is not greater than 3. I'm going to call this no. It won't work. Negative 2 is not greater than 3. Not greater. So that wouldn't work. Okay. Next one. Let x be, excuse me. Now this is 7 is 14 over 2. And this is 17 over 2. So why don't I just use 16 over 2? Why? Let me just use 16 over 2, 8. So let x be 16 over 2, which is 8. So this will give me 8 minus 4 over 8 minus 7. And that will be 4 over 1, which is 4. Now 4 is greater than 3. 4 is greater than 3. 4 is greater than 3. I come here, I put yes. Right? Then I come here, I do the last check on this interval. Let x be 17 over 2. So I could have 18 over 2, which is 9. 9. Anything greater than 17 over 2, 18 over 2, which is 9. And I have 9 minus 4 over 9 minus 7. And that is 5 over 2. 5 over 2 is 2.5, I know, but I don't want us to deal with decimals actually. Can we do this with fractions? I want you to learn fractions. It's important. Es importante. Es muy importante. So I'm not gonna, I know, and that's why I did not even bring a calculator here. So I'm gonna do this. Let's check all these like fractions. 5 over 2 and 3 over 1. Okay? 5 over 2, 3 over 1. Okay, this is times 2, this times 1. So times 2 times 2. So this is 5 over 2, this is 6 over 2. And 6 is greater than 5. So 5 over 2 is not greater than 3. It's not greater than 3. It's not greater than 6 over 2. Because once they have the same denominator, just compare the numerator. Okay? So we see, I'm going to call this no. Now I can write my stuff. Now I can write my stuff. Now I can write my stuff. So solution for x minus 4 over x minus 7 greater than 3. Here I have x minus 4 over x minus 7 greater than or equal to 3. Here I have x minus 4 over x minus 7 less than 3. And here x minus 4 over x minus 7 less than or equal to 3. So I have this here. The answer to this will be 7 less than x less than 17 over 2. That is the solution set in interval notation. Does that make sense? Okay. The next thing I will do now is to do the greater than or equal to. If I have greater than or equal to, and that will be my question 14. Greater than or equal to. In this case, it's still the same thing. Greater than or equal to. Greater than or equal to. Greater than or equal to. However, this will be included for this. This will be included here. It will not be included in 7 because 7 is not included in the domain. So this will be 7 less than x less than or equal to 17 over 2. See that? Now less than 3. Less than 3. As you can see here, if it's less than 3, negative 2 would work because negative 2 is less than 3. 4 will not work because 4 is not less than 3. Okay. If I do that less than 3, actually, this is what I'm going to get. Because some people might want me to write it. Okay, Mr. C, can you write it? Okay, I will. So I'm going to just change this here. Change this here, if it's less than 3. Question 15. Change this, change this, change this. Okay, for less than 3. So if I put less than 3, question 15. So negative 2 is less than 3. I come here, I put yes. 4 is not less than 3. I come here, I put no. Five over 2 is less than 3. I come here, I put yes. See that? So this will now give me from negative infinity to 7 union 17 over 2 to infinity. That is for less than 3. Okay? Then, less than or equal to 3. Question 16. What will it be? For less than or equal to 3, this will be from negative infinity to 7 union. Now, will I put open? Remember, 7 is not included, but 17 over 2 is included. It is included. Okay, if you put 17 over 2 now, it will work. It will be less than or equal to 3. You want us to do it? We will do it. If you put 17 over 2, it will work. So this will, if you put 17 over 2, if it's less than or equal to 3, if I have less than or equal to 3, I put 16 here. Question 16, less than or equal to 3. Negative 2 is less than or equal to 3. 4 is not less than or equal to 3. 5 over 2 is less than or equal to 3. However, we know that 7 is not included. Okay? From this, now remember, we found that 7 is not included from the modified. I know, but we are checking this now from the original. Yes, no problem. So, 17 over 2, if we check it, you will see it's included. It is for less than or equal to 3. So we will have here 17 over 2 minus 4 all over 17 over 2 minus 7. So that is 17 over 2 minus 8 over 2 all over 17 over 2 minus 14 over 2. And that is 17 minus 8 over 2 all over 17 minus 14 over 2. And that is 17 minus 8 is 9. 9 over 2 divided by 17 minus 14 is 3 over 2. So this is 9 over 2 times 2 over 3. Bam, bam. And that is 3. So 3 will be less than or equal to 3. It is included. Yes. So we now close this. We close it 17 over 2 to infinity. And that takes care of question 1 through 16. We're gonna continue, okay, part 2, and we'll do more problems. Thank you so much for listening, and you have a great night.